Hey everyone, Mr. Skelton here, back at it for the beginning of Unit 6, and this is Lesson 1, and today we're going to be talking about what a mid-segment is, and how we can use those in triangles, and so let's get right into it. So the first thing we got to do is talk about what a mid-segment is, what it looks like, and how you'll be able to recognize it. So it says, the vocabulary, a mid-segment is a segment connecting the midpoints of two sides. So in this picture right here, you can see the marking, single tick mark, double tick mark, double tick mark. That means these two are congruent to each other and these two. So X and Y, X is a midpoint for MP, and Y is a midpoint of PN. So XY, when your midpoints connect, that's what a mid-segment is. Okay? And I kind of just explained the how do we know, because you can see the midpoints on each side. So right below it, it says, is DE a mid-segment, Y or Y not? Obviously in geometry we can't assume anything. We would say that it is not because there's no markings. Okay? So when you do something with mid-segments, you have to make sure that it either tells you something as a mid-segment, or there are markings on the picture that you can interpret as a mid-segment. So there is a theorem that goes along with the mid-segment, and this is important. This is really what your homework assignment is going to be covering, is this process right here. So let me zoom in just a touch so you can kind of get a better view of it. Here's what the triangle mid-segment theorem states. If a triangle has a mid-segment, then it is 1 parallel to the third side. So if I go back up here to this picture, okay, that means that this is parallel to this. Now, if we think about what we just got done testing over with parallel lines and triangles, you're going to have to remember that these angles are going to be congruent by corresponding angles because we have parallel lines. So don't forget about that, okay? That may come into play in some of your problems. The second thing about the theorem, and this is the most important one, it's not only parallel to the third side, and it is, let's see, what did I want to put there? If a triangle has a mid-segment, then it is parallel to the third side and is the length of the third side. It is half. All right? It is half of the length of the third side. Okay? Another way of saying this is the third side is doubled the length of the mid-segment. Let me show you what that means. Let me give you, I don't have examples typed up, but let me show you a couple quick examples, okay? So let's just say that this is a mid-segment. So if this is 12, that would be 6, right? If this was 20, this would be 10. You can see that the mid-segment is half of the parallel side. 6 is half of 12. Or you can say 12 is doubled 6, 20 is doubled 10, all right? And I don't want you to get confused. I'll do one more quick example here. You know, if I put the mid-segment here, if I put a marking, double, double, and I put 60, and I said, what's X? X would be 30. So it doesn't matter how we draw it, as long as you can see it. X would be 30 there. So that's what I'm trying to say here. In its most basic form, that's what a mid-segment is. It's always half of the length. So when you go down to problems like this, where it says find the value of X, there's a couple different ways you can do it. You just have to figure out what works best for your brain. So it says, what is the length of DE? Well, here's D to E. Well, if I know the mid-segment is 6, I know that DE has to be 12. Well, they're also telling you that DE is X minus 1. Well, they have to be the same. So in terms of what is the length of DE, it's 12. Use the answer number 1 to solve for the variable. Well, X minus 1 has to equal 12, so you would add 1 to the other side and get 13. And X should be 13, which should make sense. 13 minus 1 is 12. 12 is double 6. Now, another way to do this problem, and this is kind of what I do, sometimes I shouldn't say always, sometimes I take the length of the mid-segment, which is 6. I know if I times that by 2, it has to equal this. So my setup sometimes would be this. 2 times my mid-segment equals the third side, X minus 1. 2 times 6 is 12. add the 1 over to the other side, we're still going to get the same thing. We're still going to get 13, just showing you another way to do it. Okay? So that's what we're going to do on the back side, is really spend our time working on these examples. So go ahead and hit pause and try this first example and then check back with me. All right. So it says find the value of x given that ay is equal to xy, or ax, and by is equal to bz. So that's important because what's that telling you? It's telling you that this segment of AB, okay, is a midsegment. So I know that this right here, AB, equals half. I'll show you two ways to set this up. Set up number one. 3x minus 1, which is a midsegment, is equal to half of this, which would be 17. So I could add 1 and get 3x equals 18, and x would equal 6. The second way to set this up is I know that if I double my midsegment, so 2 times my midsegment equals the third length. So that would be 6x minus 2 equals 34. I would add 2 to both sides. I'd get 6x equals 36, divide by 6, and I'd get x equals 6. So you get the same thing, okay? It's just kind of how your brain wants to think about it. Next example. Find the perimeter of ABC, which is the big triangle, given that D, E, and F are all midpoints. Well, if these are all midpoints, you could put these markings in here if you wanted to. You don't need to do this, but that's telling you that those are all midsegments. So this takes a little bit of time, and sometimes it's a little confusing for students. If this is 8, you know this bottom part here has to be what? Double that, so that's 16. And if you need to turn your paper around and kind of look at it like this, here's the midsegment of 3. So what does this whole length over here have to be? It has to be double that, which is 6, right? And if you need to look at the 7, here's 7. So it's side that's parallel to it. What's the side parallel to it? Right here. So 7, that means this has to be 14. Okay? And then it says to find the perimeter of the big, larger triangle, ABC. So 16, or you can do it this way. 16 and 14 make 30. 30 and 6 make 36. Now the question underneath, it says, how does the perimeter of ABC compare to the perimeter of DEF? Well, ABC was 36. DEF is the smaller triangle in purple. So 3 plus 7 is 10, 18. So how do those compare? It's half. Okay? The smaller triangle is half. 18 is half of 36, which should make sense because midsegments are half of the parallel side. Okay? Here's some tougher examples down here at the bottom. Go ahead and hit pause and try those, and then check back with me, okay? All right, so when we're looking at finding x, here's x, and it just looks a little confusing because I have more than one midsegment. This is a midsegment here, this x. So this x and its third side is 28. We know that this is half of this, so that's not bad. That's 14. Right? X has to be 14 because it has to be half of 28. 15 is connected with this y plus 6. Well, I know that you can do this a couple different ways. What does this segment right here have to be if you know this is 15? This has to be 30. So some students will go 30 equals y plus 6, and they'll get y equals 24. Or you can double 2 times 15. You can take your midsegment, times it by 2, and set it equal to the other side, which is y plus 6. And you're still going to get the same exact setup and solve, and you'll still get 24. Okay? This one's kind of tough. Again, this is where I would take my midsegment, which is, it says the line is a midsegment, so I know that's what it is, which implies those markings. I know that if I double my midsegment, x plus 4 is my midsegment, if I double that, it has to equal its parallel side. So I get 2x plus 8 equals 4x minus 2. I'm going to solve for x here, so I'm going to minus my 2x and add my 2 to the other side, so I get 10 equals 2x. Divide by 2, and I should get 5 for x. Now some people may get stumped on how to solve for y here, but because this is a midsegment, I know that these segments are equal. So set for y equal to the 6y minus 6. I kind of distributed it there in my head. So if I minus 6y over here, I get a minus 2y equals negative 6, so y equals positive 3. Last problem here. Good question, kind of make you think a little bit. Ask you for the measure of angle VUT. VUT. So I want to know what this angle is right there. VUT. Remember, the middle letter is always the angle. Given that V and U are midpoints. So I know that V is a midpoint. I know U is a midpoint. So that means this is parallel to this, right? Mid-segments are parallel. This kind of goes back to what we talked about at the very beginning. Now, if these are parallel and this is 81, that means this has to be 81. Why? Because of corresponding angles, right? And if that's 81 and that's 32 and this is a triangle right here, I can just take out my calculator, right, and go 81 plus 32 equals, subtract that from 180 because we know a triangle makes 180, and I get 67 degrees. So that should be 67 degrees. 67 degrees. Explain, you can explain that kind of, you can say we used corresponding angles because we had parallel lines, and we used that the triangle sum is equal to 180, and we just did some basic subtraction. Call it a day. Okay? So that's our lesson on mid-segments. Really the biggest thing that you really want to take away from this is the theorem and how it applies to problems. So right down here at the bottom, this is really what you want to focus on, is how to set these up and understanding that they're parallel lines as well. If you have any questions, we'll talk about it in class. See you later.